let's do a quick review of the join. We briefly mentioned about join last week. So we said sometimes we want to like get data that is not only in one table. So for instance, let's say you want to find the grades for all the students. And for example, a student name, student IDs, these are in the student table. And I mean, finding the grades of students like on the courses, okay? The courses are in the course table, student information in the student table, and then the grade is, for example, in the enrollment table. Then because these information are not only from one table, you cannot just simply write, for example, from a student or from course. You have to write all of them, and you have to join the tables. So if you want to get data from more than one table, that is when you are using join. There are several ways to do that. One way, if you remember, is just without using join explicitly. Instead, that's the very easy way, right? You just write, for example, select whatever columns that you want, right? From table 1, table 2, right? Table 1, comma, table 2, or even if you have more tables. And then instead of explicitly writing join, we just write it this way, and then we just join the two tables based on a common field. Now, as I mentioned, most of the time the common field is the foreign key, but sometimes, and we'll see the example, you want to join the tables based on another column, which is a common field, but that's not a foreign key. Okay, so for example, in the staff and organization table that we have, if you see here, what is the common field that is a foreign key? Department number, right? So department number is in the staff table as a foreign key and primary key in the organization or department table, right? What is another column that is common in both tables? Manager ID, right? Or manager, which is actually the manager ID in the department table, is the same as a staff ID, right? It doesn't matter what is the role, if it is manager, sale, or anything, still it has the same employee ID or employee number, right? So staff ID is the same as manager ID, so that is another common field. And we'll see an example of join for both, like using a foreign key or using another common field that is not a foreign key. So how do you do that? The first way is just select, writing the column that you want to select, and then from tables, for example, T1, T2, where T1, now let's say, for example, using foreign key, right, is equal to T2 primary key. So that is the common field. So now this common field could be, for example, department number, right? Now, let's see an example. We want to find, for example, course code, course name, and instructor name for each course. So course code and course name are in the course table. Instructor name is in the instructor table. So we want to select, so up to here, we know that we want to write select course code, course name, instructor name from course, comma, instructor name, instructor, which is the instructor table. Now we also want to join the tables, right? Because these are two tables, we want to get data from both, so we have to join two tables. So we write the columns that we want to select, from which table we want to select them, and you always can, this is like I think is more readable and more recommended way. Instead of writing all the name of the table, which might be like really long, just using an alias, right? For example, from course as C and instructor as I. So whenever you want to use course instructor, then you can just simply write C or I, right? Now you want to like link two tables, so you use the foreign key here, for example, where C instructor ID, which is course instructor ID, is the same as instructor ID. So now you are joining the course table, right, to the instructor table using the instructor ID, which is the primary key in the instructor table, and is foreign key in the course table, right? This is how you link them. And if you remember in the diagrams that you had in your data modeling, when you were linking these two tables, it showed you, for example, this link which is through the foreign key, right? That is the common field between the two tables. Now you can always also order by or sort the results based on any column that you want. For example, you can write order by course code, right? Going here quickly for the second one. Now we want to get course code, course name, and a student name for each course, okay? So course code, course name, and a student name for each course. Is this correct? Was this the question? Course code, course name, and a student name? Yeah, a student name for each course, okay? Now, before writing anything, I want to show you what is existing in each table, right? So this is selecting star from all the tables. So the first one is the instructor table. So these are the fields in the instructor. These are the fields that you have in the student table. So you can get the student name from the student table. Then course code, course name are in the course table. And then we have also a student number, course code, and grade in the enrollment table. So these are the 4 tables that you have in your database. Now, we want to get course code, course name, a student name for each course. How do you write this? So first of all, as usual, you always start with select, right? And you write the columns that you want to select. I told you I recommend you write the from here, okay? So for example, from course and student. Why? Because if you now write the column names, even if you don't write the name correctly, or if you don't remember the name of the column, it gives you the suggestions here, right? Because I mentioned, for example, the course table, so it suggests me the name of the columns. So for example, I want to get course code, I want to get the course name, right? And also a student name. But a student name in the student table was in the form of first name, last name, right? Now, I have some issues here. I want to come back to it later. Now, because we are selecting from 2 tables, we want to also link the tables together, right? How can I link the course table to the student table? And these are the columns that we have in the student and in the course. So we use, so what I wanted to mention is that in the slide, I use enrollment table because most of the time you may not have advisor ID in the student table. So I used it for another example of the different types of relationship and cardinalities, like one-to-many, many-to-many, and so on. But imagine if you have, right now, a student table and course table have this instructor ID as the common field, okay? But that is not what we use here, okay? So if you remember, the relationship between a student and the course, right, is through the enrollment. They have many-to-many relationship. We say each student can enroll in multiple courses, and each course can have many students that are enrolled in those courses, right? And because they have many-to-many relationship, we added an enrollment composite or associative entity, which is here as an enrollment table. So you can see the enrollment table here, okay? So back to our query, if you want to join course and a student, there is no common field for the enrollment that you can join these 2 tables based on that, right? So what do I do is that I add the enrollment table, right? Because that is the table that was associative entity in our data modeling that we used for connecting the course table to the student table. Now, if you see, now you see like these curly red line for the course code. Why is that? Because we didn't specify from which table. We have course code in several columns. So we have the same column name, for example, in the course table and also in the enrollment table. So we just want to specify, for example, from the course table. If you write this way, you don't see that curly red line anymore. So whenever you are joining tables, if they have like the columns with the same name, you have to specify. Or a better and a safer option is that you always, for each column, you specify the name. So for example, you write course name, and for example, a student first name, right? From course, a student, and enrollment. This is another way. Or a simpler way is if you write, for example, course as C, right? A student as S, enrollment as E, for example, right? And then here, instead of repeating course, student, and like all those long names, you just write C, course code, course name, and then S, first name. So they're all the same, okay? So far, we've selected which column we want to see from which table. We added the enrollment because a student and course do not have any common field or common column. So we are using associative entity or enrollment table so that we can connect those two tables. And this was the situation in the data modeling that we had. So we had a student here, right? We had course here. And then if you remember, we added enrollment because these two have many-to-many relationship, and we explained why we cannot like directly link those two tables, and we add an enrollment table. So that's the same when you want to join the tables, a student and course. If you want to join them, you always have to use that enrollment table to be able to do that. Now, how do you join them? First, you have to join a student to enrollment, right? And then enrollment to course. So you have like two joins. One is between the student and enrollment. The other one is between course and enrollment. So where, for example, course, what is the common field between course and enrollment? You can check, right? We know that it's a course code, but just to make sure, course code, right? So course code here is the common field between these two tables. So course code, but I don't write the course completely because I used alias C. So C course code is E course code. And okay, so far we joined course to the enrollment table. Now let's say we want to also join enrollment and a student so that we complete our joins. A student ID is the same as enrollment. Now, the student ID in the enrollment table is used with the name of a student number. So we said that foreign keys sometimes we can use like different names, right? But they refer to the same column. So where a student ID is equal to enrollment a student number. So that is how we join the tables. So if I now run these, I get the course code, course name, and the student name for each course, right? Now you can always also use order by. So for example, order by, I don't know, course name, descending. If you write that, then you will get the result based on the course name in descending order. If you don't specify anything, you get this in ascending order, which means that artificial intelligence will come first. So if I run this, the AI course will come first because it's alphabetically before data mining, and that is alphabetically before machine learning. While if you use descending, it is the opposite way. Now, so this is clear, right? And you can also, for example, let's say you also wanted to find the grade for each student, right? No matter. So which table is grade from? Enrollment table, right? The grade is in the enrollment table. So we already have the enrollment table here, so we can select grade. Why doesn't it show curly red line here, even though I didn't specify from which table?
It's only one.
Yeah, because we only have grade in the enrollment table. Okay, so you can like skip that, or if you do it like enrollment dot grade, that's also correct. Okay, and then this is if we want to like, for example, see based on the grade, and then we also want to see first without order by. Okay, so now we see also the grade of the students, or you can also order by grade. Okay, and then shows you in ascending order, which is the default. Now this was to like joining 3 tables. Now you can do the same way to join like 4, 5, like how many tables that, whatever number of tables that you want. So for example, now we want to get the course code, course name, a student name for each course taught by Mona. So up to here is the same, right? So I repeat the query, but this time taught by Mona is added. How can I do this? Don't check the answer. So we want to get the course code, course name, and a student name. So up to here, we need the course table and a student table, right? So we need select from a student and course, right? And it doesn't matter in which order you write. And then we also want, for example, course code, course name, right? A student name. We don't have a student name, right? It was first name. So if you just write a student dot, it shows you all the columns that are in the student table. So you can see that, for example, it's first name, last name, and just select it here, okay? Or for example, you can see that instructor ID here is used as advisor ID. So just write this way. And from a student course, as we mentioned before, we also need to use the enrollment table because they don't have a direct relationship, so we use enrollment. Now we also need another table, which is the instructor, right? Because we also want to find the courses that are taught by Mona. So how can you reach to the instructor that we're teaching that course, having like the instructor table, right? So also the instructor table. Now we want to like join the tables together. So so this is the first form of join that we use today, where, for example, course code is enrollment course code. So first we want to join the course and a student, so that we have to use the enrollment table, right? Because we cannot directly connect the student and course. They don't have a common field. And a student ID is enrollment a student number. And so we are not done yet. We also have to join the course with the instructor, right? And course, so do we have, yeah, instructor ID here. That instructor ID is instructor ID, okay? And then you can always sort your result if you want. So here we just run this, and here is the result of the second query. Just give me a second. So this is the result of the second query here. And so this one. So for each course and course name, we have, okay, I didn't select the instructor name. So here you also want to see, for example, if you did it right. So instructor ID, for example. So for instance, you can see, maybe you want to like see the name of the instructor, right? So in that case, you use the first name. So here, if you see, now you have the course code, course name, and first name first name for the student, first name for the instructor, right? And so here you have, for example, a student first name, instructor first name, course code, and course name. And so that was joining like 4 tables. And so this is joining tables with different links. So if, as you can see, now staff and organization tables can be linked through 2 common fields. One is the foreign key, which is specified here, department number. The other one is the manager, which is the same as the staff ID, okay? Now, these are the 2 tables that we have. So another example, finding people with job type as manager in each department, in each division, okay? I don't go back to a SQL query like the Azure Data Studio again, because we already have this. I just want to explain so that I also explained like inner join, outer join, so I just want to have like enough time to explain that. Now, if you want people with job type as manager in each department, in each division, how do you do that? So don't look at the answer. So first of all, the job type is provided in which table? In the staff table, right? So you need to find people that are a staff name, for example, and their job. So far, we want to select from the staff table. In each department, we also have the departments in the staff table in each division. So that is like the part that we need to join, right? Because the division is not provided in the staff table, that is provided in the organization table. So we need to select a staff name, job, department number, right, and division from the 2 tables that we have, like these 2 columns, which are table organization and staff. And because the name of the columns were unique, so you could use like without like writing, specifying which table, but if that is the common name between 2 tables, then you have to specify. Now you have to join tables based on the foreign key, which is the common field, and then you can add your condition. So up to here, it returns you all the people, right, from showing you all the people, for example, from both staff and organization. You can see, for example, where is the division of like all the staff, right, all the employees, if you want to see the division of like all employees. But if you want to see only the division of like people whose job is manager, then you also have to add the condition that the job is manager, because you don't want to see the division for those who are working in sale. You don't want to see the division who are like for employees that are working in marketing and so on. You are only interested in the manager one. And as usual, you can also order by any column. So in the exam, I may explicitly ask you, sort the result based on this column, and then that is when you have to use order by, okay? So I will specify that if needed. And so here is just explaining. So it finds the job manager in the staff table, right? And these are the departments associated with them. And that is how it linked like the 2 tables together, right? So this is how it's linked. And based on this, now you can also find the divisions. Second example, finding department manager in each division. So how can we do that? Department manager, where are department managers? Which table? Organization, right? In the organization, you have the manager IDs. So you have there in each division. So that is also there. But why do we need a staff table? Yeah, because we want the manager name. And what we have in the organization table, we have manager ID, okay? So manager ID and division are provided in the organization table, but the problem is that we want the manager name, which is in the staff table. So we have to join these 2 tables because we need the staff name. So this is an example of joining 2 tables without using foreign key. So this time we are joining these 2 tables based on another common field, which is the manager. And I'm going to explain in the next slide why did we join them based on manager ID and not based on department number. And I'm going to show you actually the difference, okay? So if you write, for example, select, what do we want? Department manager, manager name in each division. So we want staff name, department number, and division from organization and staff, right? Where organization manager, which is manager ID, is staff ID, right? This is how we joined it. Now I'm going to show you the difference if you join it based on the department number. Okay, I have to specify which table, for example, organization department number. Now this is the result, right? Now what if you join the two tables? What if you join the two tables based on the foreign key? So I'm repeating the same query here, okay? Now this time, instead of joining them based on manager ID and staff ID, I'm joining them based on department number, okay? Staff department number. So I want you to see the difference. So this is the difference. So the first one, join or link the tables based on the staff or managers, okay? I'm also going to add the manager here so that it's more clear. Manager. So, okay, now this is more clear, right? So when you join the two tables based on the common field of manager or staff ID, now for like each of these managers, right, you find, for example, department number and division. But if you are joining them based on department number, now you can see like multiple managers repeated, right? So that is the difference. Now, this is just more explanation here. And for example, this is how we join based on manager ID, so that it get the manager ID from the organization table, match it to the staff ID in the staff table, right? From there, it can find the staff name, because now we link the two tables, so we get access to the staff name, which is actually the manager name, right? And then do it for all the fields. And here are just the screenshots, just more example if you want. So this is if you don't want to like use this way to join the two tables. Instead, you want to explicitly write join, okay? So far, we didn't use the word join, right? So if you want to like explicitly use the join, the same procedure, just the syntax is different, okay? You select the columns that you want from table 1, join table 2, right? So before you were writing from organization, comma, staff, now you write organization join staff, and then you have to use keyword on specifying which column. Is it a foreign key? Most of the time, yes. Then you use, for example, linking the two tables based on the foreign key. If you have more conditions, like because you want to like find it only for the job type manager, so you add the condition where job is manager. And as usual, if you want to like sort the results based on a specific column or columns, you use order by at the end. This is just a screenshot. You can play with it later. Just quickly explaining different types of join that we have. So we have inner join, outer join. So if you don't specify anything, you just write join, that is inner join. Okay, so it's the same. Now, if you can remember these pictures, you will never confuse joins, okay? So the inner join, it returns everything that is common in both tables, okay? So it only returns the records where there is a match in both tables, and it doesn't like allow any null values, okay? So it only returns everything that is found in both tables. Now, for example, if, for example, some students do not have instructor, or some instructor, for example, are not teaching any courses, okay? It doesn't return null. It's not like instructor null for the course. Or it's not, for example, if a student doesn't have an instructor, it's not like a student and then for instructor null. It doesn't allow that, okay? So if you are using inner join, it only return if there is a matching value for both tables. Now, when do you use outer join? If you wanna like, it depends whether you use like left, right, or full, okay? If you use left, it means the table that is on the left, you want everything from that left table, okay? Even if it is null. So you want everything from the left table, even if you don't find any matching for the table on the right. If it is the right table, you want everything from the right, right? And then full, if it is like returning everything from table 1 and table 2. Now, how can we explain it with this example? If you write, for example, select course code instructor name from course and instructor, and you use left outer join or just left join. Okay, so you can write left outer join or left join. You can write right outer join or join. They are the same. So if you write, for example, left join, course left join instructor, which table is your left table here? Course, right? This is the left table. It's in the left side of the join. And this is your right table. And we said the left join returns everything from the left table. So in this case, it returns all the courses, even if they don't have any instructor, okay? So it returns all the courses, even if the instructor value is null. If you used inner join, it only returns wherever there is a match or a value in like both tables and doesn't include the nulls. Now, what if you use right outer join or right join? If you write from course right outer join instructor, what would be the difference? Returns everything from the instructor table, right? So what does that mean? Yeah, so what null values in which column? Even if there are some instructors that are not teaching courses, so the course value for instructor is null. So if you have like right join between course, right join with instructor, okay? So this is the table on the left, right? Because this is the left side of the join. This is the table on the right. Now, because you use right join, we want everything from the instructor table, right? Even if the corresponding value in the course table is null. So it means, in this example, in the context of this example, it means returning all the instructors, even if, let's say that instructor or that professor is research stream and doesn't teach any courses, for example, this semester, okay? So it returns you, for example, Mona, Alex, so these are the instructors, for example. Godfrey, and so on. So this is your instructor. This is your course. Let's say Mona course database, teach course database. Alex is null, doesn't course anything, doesn't teach anything. And Godfrey, for example, AI, and so on. So it also returns this, okay? But if you use, for example, course join or course inner join instructor, it doesn't return this, okay? It only returns those values that are matched in both tables and ignore all the nulls. What if you write left outer join here or left join here? If you write, for example, course left join instructor, it means you want everything from the left table, which is the course, right? And the matches, for example, on the right. But from the course, you want everything, right? So for all the courses that you have, right? Even if those courses do not have any instructor. So for example, you have I don't know what course, data mining course, but we are at the point that we haven't decided who is the instructor, we don't know yet. So This is null, so it returns that. So it returns also null here. So is this clear? Okay. And then union is just combining the result from, like the result of the select from, for example, 2 or more tables. It's very common that you confuse union with join because they are both like somehow combining tables, right? But there is a big difference. When you join tables, you are linking them this way. So, for example, this was course table, this was instructor. The result return you like a larger table in terms of number of columns, right? So it extend them like this, right? It add more columns. So we say we want to select course code, course name from the course, a student name, and for example, a student ID from a student, right? So what it returns is this. So it returns a course, for example, code, course name, a student ID, a student name. Now, when you use union, you want to select like just maybe the same things, but from different tables. So you want to make sure that your tables, first of all, what is the condition? They should have the same number of columns because it only add the 2 tables like this. So this is your first table. Let's say you have 3 columns. This is table 1. If you use union, table 2 is added just after table 1 this way, okay? So that is the difference with join. And now, can they have like a different number of columns? No. How can you do that? Like if, for example, table 2 has, let's say, 6 or 7 columns, how can you union them? So the union of T1 and T2, table 1 and table 2 is also a table. Table has a specific number of columns, either 3 or 6, which one? So if you want to like union the 2 tables, you want to make sure that they have the same number of columns, also the same data type. So for example, let's say you want to like find all the employees with less than 3 years employment. Okay, so the years of employment be less than 3, and applicants with more than 14 years, for example, education. So the first part, you can write, for example, select star from staff, where years is less than 3, right? And then you have another table, let's say applicant, where, for example, 14 years of, more than 14 years of education, where, for example, education level is more than 14, okay? So this is an example of union. So for this type of query, you can write the first one, then union, and then second query. It's very simple. So they are both like simple queries. You just use the union in between. The only thing that you have to note is that, first of all, the 2 tables here, staff and applicant, they should have the same number of columns. If a staff has 5 columns, applicant should also have 5 columns because the result is something like this. Okay, so it gives you the result like this, so it should be the same number of columns. The data type also should be the same. So if you see here, the first query, the condition is on the year, here is also on the education level, which is also the number of the years, and then we could use the union. And so I think that's enough for today. I'm going also to explain this. This is a join of a table with itself, which I explained before. If you remember, I said sometimes you can like just join one table with itself. So this is an example. For example, you want to find the employees whose salary is greater than the salary of managers in the same department. Now, when you want to write this query, like any other query, how do you start? Starting from the columns that you want to select from, right? What are the columns? You want employees, which are staff name, right? You want the salary. Salary was also in the staff table, right? And salary of manager. Again, salary of manager is in the staff table, right? Because in the staff table, what did we have? If you see the staff table, so showing just everything in the staff table. So here is the, here's the staff table, right? So we have a staff ID, staff name, department, job, year, salary, and so on. So we also see who are the managers here because we have the job column. We have the staff name. And the query is asking whose salary is greater than the salary of manager in the same department. So whatever column that we want exists in the same table, right? So we want to find the salary of the staff. So for example, selecting salary from staff, up to here is clear. But we also want to find the salary of managers. We also want to find, for example, select, for example, start from salary from staff where job is manager, right? Both of our queries or nested queries exist in the same table. So we do not want to join tables. We are just basically comparing a result of like two queries within the same table. One is salary of employees, right? The other one is salary of managers, which again we can retrieve based on this same table. That is when you can use correlation variables, okay? How? Like this. So you write, for example, select, now ignore X and Y for now. You just write staff name, salary, because these are the columns that you need. So let's say you write just select staff name and salary. Salary. Every time this happens from staff, right? Now, where the job is manager, right? So the problem is this one returns you this, right? So this one returns you only the salary of the managers. And if you write, for example, select this, you find the salary of everyone. Okay, now we want to use correlation variables so that we join the table with itself. So we join a staff with a staff again. Because they both have the same name, they are the same table, you can just write X and Y, A and B, or any name that you like, okay? As, for example, Y, okay? Then you write from which column you want each of like these tables, right? So you want the salary from X. You also want the salary from Y, right? And then the staff, for example, from X, right? Where X job is manager and then all the conditions. So you have X staff name, X salary, Y salary, where X and Y both are the staff table. The only reason that we used it because we are using like two different like queries within the same table. Now you join the table with itself, right? Using the department number, which is the key. And then you also have the conditions because you want to find the salary of the manager. So one condition is that the job is manager, right? The other condition is that job is not manager, right? Because you want to find the salary of employees who are not manager, compare it with the ones that are manager, and then returning those that have salaries higher than their manager. Maybe they are in sales department and they like work with commission and they may even earn more than their managers, okay? So that is why here you have these weird like SQL statements like Y job manager once equal to manager, the other time not equal, and then you also want X salary greater than Y salary. Why? Because here Y returns to the manager, right? X returns to like a non-manager role. That is non-manager role, right? X job is not manager, and this is a manager role. Is this clear? Okay. And so I just put the screenshot of like these comments for you. So if you just, for example, select the start from staff, where job is not manager or where job is manager. So the first one, returning that are not manager, which is this one. The second one, returning all employees that are manager, which is this one. And then the last query, returning only those employees whose salary is greater than their manager. Okay. So if you check those two tables, you see that these two staff, like Pernell and O'Brien, they have a salary which is greater than their manager salary. And yeah, that's it. Okay. Do you have any questions? Okay.